Okay, today we're going to be talking about how to solve inequalities by using a sign chart. All right, so the first thing, it gives us an equation. Let f of x equal this equation, and we want to determine the real number of values of x that cause the function to be equal to 0. When is it positive and when is it negative? All right, so we can make a sign chart or a number line. And what we want to do is we want to set each factor equal to 0. So x plus 3, set that equal to 0. We get x equals negative 3. So negative 3 is going to go on our number line. Now, x squared plus 1, we're going to set that equal to 0. And we quickly realize that we will not get any real solutions here because you cannot square a real number and get negative 1. So therefore, we don't get anything from that. Also, we can also say that this will always be a positive number because anything you square is going to be positive. When you add 1, it's still going to be positive. So I'm going to put a plus sign right here just so that later on we'll know what that is. Now, we're going to set the last one equal to 0, x minus 4 equal to 0, and we get 4. So that's going to be the next number we put on our number line. Now we're going to plug in a number bigger than 4 in this region, so we'll say 5. 5 plus 3 is 8. We've already determined that this is a positive number, so we'll just say it this way. It's a positive number times a positive number, and then 5 minus 4 is 1. That's also a positive number, so that's going to be positive. Now, what you don't want to do is plug in numbers in these other two regions. You want to use what's called the multiplicity of roots. We talked about this a little bit in section 2.3. And the idea is that if the power is odd, the signs are going to change. All right? Think of it as an odd function that has let's say it has an exponent of 1. It goes through, just like we did in 2.3. And then the other one that's odd is a slide. And so that would maybe look something like this. But it also goes through. So it goes from negative to positive. Negative to positive. Now, even functions are going to stay the same. So the signs are going to stay the same. All right? Think of it as a parabola, just like we did in 2.3. Positive, positive. So what we do is at 4, we're going to go to this particular factor, x minus 4 squared, and we're going to say, well, it's raised to an even power. So that means at 4, the signs are going to stay the same. So we already know that's plus. And then at negative 3, we're going to go over to this power, x plus 3, and it's raised to the first. That's an odd number. So the signs will change from where it is. It is plus here. On the other side, it will be negative. So therefore, where is the function 0? So part A, well, it's 0 when x equals negative 3. That makes it 0. And also when x equals 4. And then when is it positive? Well, it's positive between negative 3 and 4 in union with 4 to infinity. Now make sure you don't go from negative 3 all the way to infinity because it is not positive at 4. It's 0 at 4. So you have to stop at 4. And then where is it negative? It's negative at negative infinity to negative 3 with a parenthesis and not a bracket. Okay, number 2, we need to solve when this function is greater than 0. When is it positive? So, if you notice that in the first example, it was already factored for us. Here, we have to factor it similarly in the way that we did 2.4 and 2.5. So we've got to factor it. Now, that requires synthetic division. So, I already know just from previous working of this problem that negative 2 is going to be the number that causes us to have a remainder of 0. So let's see if we can work that out. Bring the 2 down. Negative 2 times 2 is negative 4. That's going to be negative 11. Negative 2 times negative 11 is positive 22. 22 minus 10 is a 12, and then negative 2 times 12 is a negative 24, and that gives us 0 as a remainder. And so now that we know that one of our factors is x plus 2, we can put that there. And then the other one we have to factor. So this is 2x squared minus 11x plus 12. We want to factor that. So 2x and x, and let's see here, 3 and 4, and we'll make them both negative. Let's check that out. 2x times x is 2x squared. 2x times negative 4 is negative 8x. Negative 3 times x is negative 11x. And then negative 3 times negative 4 is positive 12. So our factors are 2x minus 3 and x minus 4. And we want to know when this function is greater than 0. So once again, we make a number line. And the nice thing about this is that all of these are raised to the first power, first power, first power. So the signs are going to change every time. So let's go ahead and put our numbers on here. So this is negative 2. Here, if we set this equal to 0, we'd add 3 and divide by 2, so that would be 3 halves, or 1.5. And then x equals 4. Now let's plug a number bigger than 4 in, like 10. 10 plus 2 is a positive number. 2 times 10 is 20 minus 3, that's a positive number. 10 minus 4, that's a positive number. A positive times a positive times a positive is a positive. And because the signs are odd for all of them, the signs are going to change, then it's going to change, then it's going to change back. And so now we can say that it is greater than 0. I'm going to circle it. It's greater than 0 here and here. So we need to write those intervals down. So it's going to be from negative 2 to 1.5 in union with 4 to infinity. Okay, example 3 says solve this polynomial inequality graphically. Anytime we see the word graphically, that means we need to use our calculator and not try to do it by hand. So the first thing we need to do is we need to get all the terms on one side. So that's going to be x cubed minus 6x squared. Adding 8x to both sides brings an 8x over here. Subtracting the 2 is going to be minus 2, and then less than or equal to 0. So basically we need to graph this function on our calculator and figure out where it's less than or equal to 0. Pay attention to the less than or equal to. So let's go ahead and do that. Okay, so here we have our function f of x equal to x cubed minus 6x squared plus 8x minus 2. We want to figure out where it's less than or equal to 0. That means we have to find our zeros. So we're going to go here to Menu, we're going to go to Analyze Graph, and we're going to hit 0. When we do that, a little line comes across the board, so we're going to hit left bound and right bound, and we see there's a 0 right there. And let's go ahead and do the other one. So Menu, 6, 0, left bound, right bound. We've got another one. So let's move these out of the way so we can see them all. Okay, and then we're going to move this one up here. That way it doesn't get in the way of the one that we're trying to find. So last one is we're going to hit Menu, 6 and 1. And we're going to do left bound, right bound, and there you have it. Now, when is it less than or equal to 0? Well, that would be when it's below the x-axis or equal to 0. So that would be from negative infinity up to 0.325. And then it's below the x-axis again in this region, so that would be from 1.46 over to 4.21. This would be how we would write our answer, negative infinity, comma, 0.325 with a bracket because we're interested in when it's less than or equal to 0. And union with bracket 1.46, comma, 4.21 bracket. Brackets because on 1.46 and 0.325 and 4.21, it is equal to 0 at that point. So we want to include brackets. All right, example 4, let f of x equal 2x plus 1 over x plus 3x minus 1. Determine the values of x which cause the function to be 0, and then when is it undefined, and then when is it positive, and when is it negative. All right, so we're going to make a sign chart. All right, and on this sign chart, we are going to put the following numbers. We're going to set each factor equal to 0 on the top and bottom. So 2x plus 1, set that equal to 0, we get x equals negative 1/2. And then on the bottom, we're going to get x equals negative 3 and x equals 1. All right, so we are going to put negative 3 on our number line. And then up here, I want you to put either the letter 0, actually either 0 or U for undefined. If you are dividing by 0, that means that the function is undefined because you can't divide by 0. So at negative 3, it will not be equal to 0. It will be undefined. So I'm going to put a U right there. And then the next number is negative 1/2. Now negative 1/2 would cause the entire function to be 0 because the numerator will be 0. Make sure you understand that. When the numerator of a fraction is 0, like 0 divided by 4, the whole number is 0. So the way you get a fraction to be equal to 0 is if its numerator is 0. If it's undefined, that would be if its denominator is 0. All right? So this, I'm going to put a 0 here. And then over here at x equals 1, I'm going to put, once again, a U for undefined. And then for each of these, I'm going to raise it to the first power because that's what it's raised to. First power, first power. Now, we're going to... So we can answer questions A and B. So letter A, when is the function 0? The only number that would make it 0 is when x equals negative 1/2. All right, when is it undefined? It's undefined when the bottom is 0, so negative 3 and 1. So that's pretty simple. Now we're going to pick a number bigger than 1, like 5, and we see that the top is going to be positive. The bottom is going to be 5 plus 3, that's positive, times 5 minus 1, that's positive. So we have a positive times a positive, which is a positive. So we have a positive divided by positive. That's going to be positive. So this region's positive, and then we can use, once again, the fact that these are raised to odd powers. So I don't want to go too fast through this. If you're trying to see what is going to go in here, you have to look at the factor that produced this number 1. That's going to be x minus 1. That particular factor is raised to an odd power. So that means the sign is going to change from where it was. So it's going to make it negative. Now you go over to the factor that produced the negative half. That's 2x plus 1. Oh, that's raised to an odd power. So the signs are going to flip again. Now you go to the factor that produced the negative 3. That's x plus 3. That's raised to the first. That's an odd number. So the signs are going to flip again. So letter C. When is it positive? It'd be positive from negative 3 to negative 1/2 in union with 1 to infinity. And notice I'm not using brackets because it's not positive at these numbers. It's either 0 or undefined at these numbers. And then D, where is it negative? Well, it'll be negative from negative infinity up to negative 3 in union with negative 1/2 to 1. All right, example 5, we want to solve this rational inequality by combining fractions. Now, it's very important to pay attention to this problem, please, because in section 2.7, the way you solved equations is that you multiplied all the way across by the lowest common denominator, and it just canceled out all of these denominators and created like a quadratic or a linear equation. That is not the method that you want to use here. You need to group these together by getting a common denominator. All right, so if we have 5 over x plus 3 and then plus 3x minus 1. Anytime you have an inequality symbol, you need to get a common denominator. So we're going to multiply the top and bottom by x minus 1, and then we're going to multiply the top and bottom here by x plus 3, x plus 3. All right, so now we have 5x minus 5 when we distribute, plus 3x plus 9. And all of that is over the common denominator of x minus 1, x plus 3. And when is that less than 0? So that's going to give us 8x plus 4 over x minus 1 and x plus 3. And when is that less than 0? Well, if you notice, it looks very similar to the last problem. So we'll make another number line. And on this number line, we're going to put negative 3. We're going to put negative 1/2. And above negative 3, I'm going to put the word undefined, or the letter U, because it comes from the bottom. Negative 1/2, I'm going to put the number 0, because that comes from the top. And then 1, I'm going to put undefined. And if you remember, it was plus, minus, plus, minus. It is less than 0 from negative infinity to negative 3. And you're only going to list this interval. You don't list the positive ones, clearly. And then in union with negative 1/2 to 1. And that would be where it's less than 0. So the key for this problem is to remember to get a common denominator and not multiply all the way across by the lowest common denominator. All right, example 6, same idea. We're going to set both of these factors equal to 0. So x minus 3 equals 0. That gives us a answer of x equals 3. Then x plus 1 equals 0. That's going to give us a negative 1. So we're going to make a number line. And then on this number line, we're going to put the same deal, negative 1 and 3. All right, so now we're going to test a number in each region. So we're going to, we'll tell you what we're going to put above each of these is the letter O, for actually the number 0, because if I plug in either of these numbers, 3 minus 3 is 0. 0 times anything is 0. Negative 1 plus 1 is 0. 0 times anything is 0. So both of these numbers give me 0. So now I'm going to plug in a number bigger than 3, like, oh, I don't know, 5. 5 plus 6 is, 5 plus 1 is 6. The square root of that is a positive number. Don't know what it is, but we know it's positive. And then 5 minus 3 is 2. That's a positive. So positive times a positive is a positive. All right, so now we're going to plug in something like 0. 0 plus 1 is 1. Square root of that is 1. So that's a positive number times 0 minus 3 is a negative number. That's going to give us a negative. Now, I want you to notice something here. When you try to plug in a number smaller than negative 1, it doesn't work because let's say we plug in negative 4. Well, negative 4 plus 1 is a negative 3. You can't take the square root of a negative number. So in this region, you're not going to put a minus or a plus. You'll put an x, which basically means there's nothing over here. It's undefined over there. Now, here's the tricky part. Where is this function greater than or equal to, greater than or equal to, greater than or equal to 0? Well, the first place that it is 0 is here, so we're going to put that in its own set of brackets, negative 1. You've never seen that before, I'm sure. So that's going to be in union with, we skip over this region because it's less than 0 here, and we go to the next part where it's either greater than 0 or equal to 0. That's going to be here. So at 3, it's 0, so I need to put a bracket. And then everything after 3, it's positive, so I need to put parentheses. And so that is how you'll write your answer. So sometimes you'll have an answer that's standalone all by itself. You just have to pay attention to that. Okay, last problem, same deal as all the others. We're going to set each factor equal to 0. So we get an x minus 2 equals 0. That's going to give us x equals 2. And then the other one's going to be x equals negative 3. All right, so once again, same deal, guys. We're going to make a number line. On this number line, we're going to put the numbers negative 3, and we're going to put 2. And we want to figure out where it's less than or equal to 0. So we're going to try a number bigger than 2, like 4. 4 minus 2 is a positive number. 4 plus 3 is 7, but the absolute value of 7 is 7. So a plus over a plus is a plus. Now we're going to try a number between negative 3 and 2, like 0. 0 minus 2 is a negative number. And 0 plus 3 is 3. The absolute value of 3 is going to be a positive number. Make sure you understand what absolute value is. If it's positive, it stays positive. If it's negative, it turns into a positive. So we have a negative over a positive, that's a negative. And then something less than negative 3, like negative 5. Negative 5 minus 2 is a negative 7. Divided by negative 5 plus 3 is a negative 2, but the absolute value of negative 2 is positive. So negative over a positive gives us a negative. So where is this function less than or equal to 0? Well, it's going to be from negative infinity to negative 3. Now we don't put a bracket on negative 3 because negative 3 does not make the function equal to 0. It makes it undefined. So we need a parenthesis. And then in union with negative 3 to 2. And then at 2, we're going to put a bracket because at 2, 2 minus 2 is 0 over 5. That makes it 0. So that is the answer.